Okay, today we're going to learn how to solve a complex log equation. Now, we've done some of this before. There's two things that you need to kind of pay attention to. One is from an original assignment where you had something like this. Do you remember in the one of the starts of this unit, we saw something like this? The log of base 6, 5x plus 1 equals 2. Remember that we could change any log, single log expression to an exponential equation? Is that good? Right? You understand that? This is the base, this is the power, this is the answer. So we go like that, right? 6 to the 2 equals 5x plus 1. And then we can solve this equation fairly simply. Okay, x equals 7. You got that? Does that make sense? Okay. Also recall that we did this. Yesterday, or at least the last class, we learned that there were ways that we could use the log laws, right, to simplify an expression. And what we learned that is if there's a log that has an equal base, right, that we can rewrite that as one base, right? These three we can write as one base. Do you remember how that goes? So we can simplify into one log. And how does that look? Log base A of, how do we do this? Adding means multiplying. So this would be 4 times, and this is kind of weird, we'd have an x plus 2 in there, right? And what does this 2 do? Goes to the power, right? Subtract means divide by z cubed, right? So today what we're going to do is we're going to combine those two skills to solve a log equation. Yes, that's very good. We're going to go from this to one log, and then once we have one log, we're going to move it to an exponential. You follow where we're going? I'll show you. Solving log equations, and the way that we're going to do it is using the laws and rewriting as an exponential, which is just what we know how to do. Oops. Right? We know how to do that. So here's an example. So we're supposed to solve for x. It's an equation because there's an equal sign. So that means I want to actually solve for the value, right? We're not just rewriting it like we were the other one. So our first step is to rewrite it. You notice that they both have a log base of 6, right? So how can we rewrite this? So we're going to use our laws. We are just going to look at the left-hand side. The left-hand side can be combined into one log. Do you agree? Because they both have a base of 6, right? So the left-hand side we're going to write as log base 6 of what? X times x minus 5. That's right. Equals 2. Right? The 2 is just on the right-hand side. But now you see we have a single log. Sarah, looking? Now we have a single log, right? We have one log equals something. And now we can just rewrite it using our definition of a log, right? So number one, you use the laws to combine. Now we're going to use the exponential form, which means what? What to the what? Good. 6 to the 2, and let's multiply this out, x squared minus 5x. Is that okay? Nothing earth-shattering there. We've done that before, right? You good with that? Okay. How do we solve this? Factor the x out. What? Factor it, square root it. Oh, we got all kinds of options here. What's that? Move what to the other side? Why? Yes, because it's a quadratic. It's a quadratic. It's got x squared in it. What we want to do is we want to make it equal to 0 and factor, right? That's how we solve quadratics. That's what we learned in grade 11. Okay? So we're going to go x squared minus 5x minus 36, right? We're going to do this, right? We're going to subtract 6 squared, which is like subtracting 36, right? Equals 0, and it doesn't matter where I put the equals 0, whether I put it on the left-hand side or the right-hand side. So I might as well make it on the right-hand side, right? Right? It doesn't really matter where it goes because it's a 0. Okay? And then now, factor. X minus 9, x plus 4 equals 0, x equals 9, or negative 4. You good with that? Okay, now here's the thing. There's two answers, right? No, but we do have to check it. Okay, this is one of those you have to check because when you rewrite it as an exponential, that sometimes means that you add a root that doesn't exist. Now, recall this. What would this mean? If we rewrote that, this would mean 6 to some power equals negative 10. Do you agree? Even without the x, that's what this represents, doesn't it? The power that I'm raising 6 to get to negative 10. Good, that's no solution. Well, because you can't raise a positive base to a power and get any number 0 or less. It has to be positive. Right? Remember when we graphed the exponential graph? Even when I picked really negative values, it was still above 0. So in other words, I cannot have a negative value in the answer. So here, no negative results in the argument. We call that the argument. So when I put this number back in here, like when I put in the 9 or the -4, you see when I put a -4 in here, I have a problem. Because this is saying 6 to some power gives me -4. That can't happen. Does that make sense? So therefore, -4 is out. That's called an extraneous root. I'm never sure how to spell that one. I think it should be just one. If you want a long A, you think it should be one N. Yeah. Extraneous root. So x equals 9 is our only solution. And you can see, because when I put 9 in, I'm okay, right? I have a positive value here. I'd have a 9 here, and here I'd have a 9 take away 5, which is 4. That's fine. So you have to check it back into the original. Good? So a pretty simple process, really, right? Use the laws, and it's a pretty easy example of the laws. Like the other time, we were doing really complex things with subtracting and adding, so turn to dividing and multiplying and powers. This is only like one step, right? Okay, let's try another one. Let's see. I'm going to have to leave this in blank because I'm going to have to think for a little while. Man, I'm going to have a hard time figuring this out. Okay, I'm just going to make something up here, and it's not going to work out, but I should do that. Think here. I'll pause it. Nope. We'll continue. So, again, we're going to be using the same process. Okay. So what's our first step going to be? Rewrite it. Good. Rewrite. Using laws, right? First we're going to use the laws, and then we're going to use the form of exponential, right? So what am I going to do here? Good. It's going to be log base 4. Okay, what do I have? Good. X squared, right? This 2 goes in front. Subtract means divide by x plus 1. Make sense? Equals 1. The number in front can be written as an exponent. Right? X. No, we're not doing exponentials. First, we use the laws to get them together as 1, right? Okay, so now we've got them written as 1 log. Agreed? So, squared, divide, equals 1. Now we use the exponential form. So what does the exponential form look like now? Four to the 1, right? 4 to the 1 equals x squared over x plus 1. Agree? Oh, man. It's annoying. It's not sticking today. So how do we solve this kind of equation? Right. You multiply by the x plus 1, right? Right? You're multiplying both sides by x plus 1. So you're going to have 4 times x plus 1 equals x squared. Now you can do 4x plus 4. Okay. So now we're going to have 4x plus 4 equals x squared. So x squared minus 4x minus 4 equals 0. Yeah, I just wonder if I could have changed that. You know what I could have done? I could have made that an x subtract 1, then it would work out, right? Then I'd have a plus 4 on the side, wouldn't I? Yeah, I'm going to change it to subtract 1. That would be the solution. Okay, that's good. Easy fix. Easier for me than for you, though, right? So then it's going to be a plus 4 over here, right? This will be a minus 4. Okay. And then we can factor this, right? Yeah. X minus 2 equals 0. So therefore, in this case, we only have one solution to check. It's x equals 2. Not necessarily. Sometimes equations have no solutions, right? Even if they're positive. We have to go back to see what it looked like in the beginning. Here it's fine, right? If I put a 2 in here for x, that's a positive value in the argument. Here, 2 subtract 1 is still positive, so that's okay too. That's all I need to check. I don't need to check whether it actually works out. This is my proof that it works out, but I just have to check because it's hard to prove it actually. I mean, you could do it, but it's not that easy. Okay? No, once you change it to the exponential, you've already added that extra root in there. You have to check it into the original. Okay? It will work in the exponential. Both positives and negative will work in the exponential. Yep. And here's what you have to do. If you have one solution, you have to say, give me some indication that you checked it. Check mark is good enough, or put a little arrow up there in the top and say it works. Circling is just telling me that you think it's an answer. It doesn't tell me whether you checked it or not. Here's the thing. On that previous question, like if you had done this and just written down x equals 9 and none of this other stuff, you'd have lost the whole mark. Okay? Because that doesn't tell me whether you're a student who knows that both answers are here and I only know the positive one's actually the right answer, or whether a person who just thinks, oh, there's only one answer, it's x equals 9 because I forgot about the other bracket. Okay, so you have to show me that. No, you wouldn't have to write extraneous. Okay, let's do one more. That's a 3. Okay, the log of x plus 3 plus the log of x equals 1. But there's no right. Good. Right, when there's no base, we got to write down a 10, right? So it's not written down, but you got to understand that this is a 10. Okay, so now we can do the same things as before, right? How do we do that? Log 10. I'm going to start multiplying it out now. What's it going to be? X squared plus 3x, yeah, equals 1. Okay, and then what? So that's the laws. Then we do exponential form. And we get to the 1 equals x squared plus 3x, right? X squared plus 3x minus 10 equals 0. Okay? And then x plus 5, x minus 2 equals 0, x equals -5 or 2. Now I look back into the original. -5 won't work. Everybody see why? Okay, good. It's almost always going to be the -1, except if these brackets look different, right? If these brackets would have been 3 minus x and -x, then it's actually the -1 that you'd want to work, right? So the brackets would kind of have to look different for order for the negative ones to want to be the right answers, okay? X times x plus 3. Right? Adding leads to multiplying. Yeah, I just jumped ahead and did it. Okay, I'm going to give you one more final example. And it's kind of an unusual question. It's where you have 3 of them in there, I think. See if you have one in your, or maybe you don't even have one. I'd like to show you one. Maybe on the quiz. No, there is none. Let's see if I can do it, though. Make it x plus 6. I think that will work. Yeah, that should work. Okay. I'm making this up a little bit. You have options here. You could move this to the right-hand side. I mean the right-hand side to the left-hand side, so they'd all be together, right? Do you see that? But I'm going to show you another way to do it, and this is the faster way to solve these types. You can see the thing is here that we've got 3 that are all of the same base. And this is probably the fastest way to do it. You can go like this. You can combine the left-hand side. So the left side, we're going to use the laws. And then we will have log base 3 of x squared plus 6x, right, equals log base 3 of 27. Okay? And now the shortcut here is because both the left side and the right side are written as a base log 3, we can go right to the next step. X squared plus 6x equals 27. It's kind of the same thing we did when we did the exponential equations that were the same base, right? We could just make the powers equal to each other. Here, if the bases are the same, we can make the arguments equal to each other. We can make this argument equal this argument because both of these are the same base. Okay? So that's the shortcut. You could have got that same answer with a lot more work by moving these to the left-hand side. And then you'd be subtracting it, and then you'd be dividing it, but you'd end up here anyway. But this is faster. So this is this, and then we would have to actually figure this all out, right? X plus 9, x minus 3, x equals -9 or 3. But then again, yes, looking back here, the -9 won't work. So 3 is my only answer. Okay? You got the idea? So the same steps every time, though. Use the laws to put it together. On the left-hand side, use exponential form, solve the subsequent equation, check your answers. Okay? 5 minutes.